All right. Okay. All right. So guys, for all of these, we're trying to find out what these equal. So I like putting an X there so I can visualize what's going on. Now, technically, you could probably put that into your calculator. I would prefer that you actually change that over to the exponential form. So what I mean by that is you take the base, which is 10, raise it to the x power, and that should equal 10,000. So we're trying to find the power that would work for that. So 10 to some power equals 10,000. And is that 3? 4, yeah, 4. So, because the first power, yeah, 4. So, now a way to check it is you could do change of base formula. We learned that you could actually, that one you can actually do log of 10,000 in your calculator. Remember that your calculator assumes it's base 10. So your calculator actually, if you do log of 10,000 in your calculator, it should give you 4, which is the outcome there. All right, so then this next one is log base 3 of 27. I know I was talking to Becca about this one before we left, and I had mentioned trying to look at some of the ones we had done last class. So one of the things is a square root. It's supposed to be square root, yeah. Square root is the same as the 1/2 power. Well, I thought I changed that color. I guess I need to go back here. So it's log base 3 of 27 to the 1/2 power. That doesn't seem much more helpful. What I want you guys to get at here is that I really want the log base and this number to match. So I want to rewrite 27 in a way with a different power, like with a base of 3. And so if you check 3 to the second is 9, 3 to the third is 27. So what I did here is I rewrote this using the log base 3. I chose that as my base here. What that allows me to do is when it's log base 3 of 3, this cancels. And I'm just left with 3 times 1/2, which is 1.5 or 3/2. So I'm just left with these 2 multiplied. Okay. The next one here, log base b of 1 over b. Well, already I can see I have some b's here, except it doesn't really make a ton of sense here in the way it's set up. I'm gonna, what I picture is I'd like to again rewrite this with like the same base. So I'm going to change this to b. What power do I have to do to make this 1 over b? Yeah, you got it. What is it? Negative, like a -1 power. Because b to the -1 power is 1 over b. All these rules that we talk about with exponents back in Algebra 2 and in Algebra 1 are coming back to kind of haunt us maybe a little bit. So this and this are exactly the same thing. So we're trying to rewrite it that way. Yeah, Stone.
How do you know when to do like log base 1 minus log base b? And
oh, so why that we didn't do that?
Yeah.
I was just thinking of that as I started talking about this. And let me, so you did that instead?
Yeah.
Okay, I'll talk about that in a second. Well, so this cancels. and this ends up being -1. Because technically this would end up being -1 here, Stone. So let me show you that. It's kind of crazy how this works out, and it'd be harder to find, but it works. Because log base b of b is just 1, it cancels. This cancels out to just be 1. So this really becomes log base b of 1 minus 1. Now I can't just subtract that and make that 0. So what I'm going to try and do is simplify this. What you can find out is that log of anything like of 1, so like if you do log of 1 in your calculator, it should be what?
0.
It's 0. The reason for that, I'm going to go over on this board again. The reason for that is, if I do b to the x power equals 1, anything to the 0 power is 1. So that this equals 0 here. So it's 0 minus 1, which is just -1. So we get the same thing. So you could have done the subtraction thing, it just took more work. So
Okay.
subtraction works, it just would have been, that would have been a little bit tougher if you're not comfortable with it.
Okay.
This next one now, do you guys remember what the base is when it says ln? It's e. So when it's ln, it's already base e. So ln base e of e, these two cancel and we're just left with 5. Okay. Number 5 was just trying to get you guys to rewrite that exponential form into a log form and write it in words. So if you struggled with that, I wouldn't be bent out of shape with it. Let me just show you guys what I mean. I'm assuming that you might have some questions on that one too, but this is 5. 2 to the third, or 2 over 3 to the second power equals 4 over 9. They want you to switch it to log form and then write it in words. So this is log, the base is 2/3 of 4/9 equals 2. They were just trying to get you to write that out as if you were speaking it on the phone. So log base 2/3 of 4/9 is 2. So if you didn't realize that's what they were trying to get you to do, they just wanted you to switch it over. Being able to make this switch between these two kind of comfortably is going to be important in this chapter. So being able to kind of manipulate between those two is going to be useful. All right, number 6.
I'm actually good now.
Anyone want 6? Okay, well, that's okay. That's why I asked. So this one said log base 2 of n, and then they give you some values for n. So I'm actually going to make a chart. Do they start with 0? No. It went up to 8, but or 9. You'll get the idea though once we get going on this. So you're just substituting these different values in. So I'm doing log base 2 of 1. Now you could switch this over to exponential form, because this one is one you can probably do in your head. But if you're not sure, you're just trying to go through this quickly, the way to put that in our calculator is we do log of 1 over log of 2. Now again, that would be an easy one to do by hand. It's 2 to the x power equals 1, so it's just going to be 0. Any log of 1 is going to be 0. And you just keep substituting a new value in. Log base 2 of 2. Now again, you could do that in your calculator, log of 2 over log of 2. That just equals 1. That cancels out. So these first couple are pretty easy, I guess I would say. Now this one's going to be a decimal. This would be a hard one to do in your head. So log of 3 over log of 2. That means I need to grab my calculator and do this using my calculator. So you're not able to do log of 3 over log of 2 in your head, so then feel free to grab, handy calculator here. It's 1.5 0.85. Log of 2 of 4, log base 2 of 4. Again, you could do it by this way or the short, or the by hand. 2 to the x equals 4, this is going to equal 2. But that's the same thing you would get if you put it in your calculator. And then you're just going to keep going up from there, okay? Just trying to see that you understand evaluating it. I was hoping that you'd see some patterns in there. There's kind of some cool patterns, like cool math cool patterns that show up in there. I know Cash had asked me about this. I meant to give you guys some of the problems where you had to do like the expand and like putting things together and taking it apart, and I just forgot to assign them. Like
Sorry about me.
So I'll probably end up putting something like that into today if we change our homework up, but it's good for us to practice that. But let's go to number 12. I'm assuming we need 12?
Yeah.
Okay. So this says solve 15 to the t power equals 30. Now, before we understood logarithms, I had said we could put this into our calculator. We could do 15 to the x power, and then we could go and find where does the equation equal 30. Now that we know logarithms, it's a lot easier to do this using logs. So what I would suggest, when you don't know the exponent, switch it to logs. So the log, the base we're doing is 15 of 30 is going to equal our t. So anytime I don't know the exponent, logs is a really easy way to solve it and get an exact answer. So what I do now is I just do my change of base formula. Log of 30 over log of 15. And that'll give you your outcome, which should be, what's that? Like 1.26, something like that. So that's what 15 to like the 1.26 power, if you check that, it should be close to 30. Just depends how much you round. Okay. Mean 16? It's the population, the growth? Yeah. Okay. So 16 was like our rabbit problem last time. So they throw in those years. They say the population from 1980 to 1990 grew at an annual rate of 2.9%. The fact that they are watching that for 10 years doesn't really matter to us. We want their rate. So we're going to use the 2.9%. That's the growth rate per year. Determine the number of years to the nearest year it would take to double. So we talked about quadrupling last time. We wanted to double. So we're going to pull up our formula here. But I don't know what it's starting at. I just want to know when it's going to double. So we said we're going to take that A and B out of this and just say double. So that's just going to, we want it to know when is it going to be twice the size it was before. The rate looks like this. So the rate, move the decimal over twice. Now at this point, again, anytime you don't know the exponents, I would suggest using logarithms. But when it's log base e, we can use ln instead of log base e. It's just a little bit nicer to work with. Because if it's ln, it's base e, ln of 2 is going to equal 0.2, or sorry, I always add that extra, or I leave that decimal place, 0.29t. Now, I don't really need that e there, so I can just do ln of 2, gives me about 0.693 something. Now, I'm not going to really leave that as a decimal. I'm just going to take that and divide it by this. Oops. So I left that long decimal in my calculator, and I got like 23.9 for my t. So it says, I think to the nearest year, or we'd want to round up because we want to be double or more. If we go under, it would be less than double. 24 years before the population would double. And obviously that'd be something that would be useful information to know if you work for the government or something like that. You want to know when the population of the country is going to double, kind of a big deal if that rate continues. So again, anytime you're looking for the exponent, switch to logarithms. It's more exact. We don't have to do the searching that we had to do on the calculator. So our next one here, 17, I'm just going to assume you guys wanted it. Letter C for 17 is a little strange. I'll try to point it out to you. I would understand if you missed it. Okay. They basically in C want to know how would you compare those two values or how do they relate to one another. So I would do log of 98 over log of 12. Here I do log of 12 over log of 98. And they give me my two outcomes. What I want you guys to notice is, do you guys remember there's a name when we have the fractions that are identical but flipped? It's just like a reciprocal. So just seeing that when they switch those two pieces, those are just reciprocals of one another. So like letter C, you could have said it as a reciprocal. Otherwise, they said like log base B of A is equal to the flipped version. So, I mean, however you wanted to write that, it's fine. It's just trying to get you to notice. So, but again, you're putting this into your calculator this way. And then number 18. This one we did one like it, and it had the factoring involved in it. And I will talk a little bit more about values that make sense for logarithms since we have the time, because we're going to kind of push off of her a day here. So log of x minus 15 plus log of x equals 2. When I have addition of two logs with the same bases, we can combine those. So we're going to put them together. But addition becomes what? Addition becomes what? Multiplication. So I need to multiply these. So I prefer to put that little x in the front. So when I multiply that, I have to distribute that. Now, I don't know how to solve a log like that. So again, just like if you didn't know how to pronounce a language or like a particular language, you would change it to one you understand. So I'm going to switch this to exponential form because that helps me in this case. What's my base here? My base is 10. So my base is 10. So I'm going to rewrite this in exponential form. So 10 to the second equals, it's my base and exponent. So what we just did was we got rid of the logarithm and switched to exponential form. Okay? Now 10 to the second becomes 100. So I need to solve this now. I'm going to move this 100 over. And we talked about the factoring yesterday. And not a lot about the factoring, so if you kind of like still a little bit rusty on it. We know it has to start with x and x because of that x squared. If you recall, this is where we want to multiply to get this number. We want to add to get this one. So multiply to negative 100, add to negative 15. Those are two factors. What do you think of it?
Positive 5, negative 20.
Positive 5, negative 20, yep. Like I said, I have to explain a little bit more about my answer, why I only had one answer. positive 5, negative 20. So if I go to solve these, x plus 5 equals 0, x minus 20 equals 0. This one I solve and I get x is 20. This one I solve and I get x is negative 5. We're actually going to throw that answer out, and I need to talk to you guys about that. And I didn't yesterday because we were running low on time. So like today kind of gives us the chance to be able to talk about it. So the issue is you can't actually take the log of a negative value. If I try to do log, if I put negative 5 back in here, or just even negative 5 in here, if I do log of negative 5, your calculator is going to give you an error message. Because the reason for this, let me try to explain this a little bit. I'm going to call this m. If my base is 10, 10 to the m power, that's never going to equal a negative 5. It just doesn't make sense that that could ever happen. So if we find the x value and we put it back in, it ends up being that we're taking the log of a negative. It doesn't work. So that's one thing we probably need to add to our notes somewhere. We can kind of put that down and make sure we get that, but you can't take the log of that negative. So let me find what we're going to do here for today. So I might give you guys a moment to break here.